I I am 11 years old. My school name is Sarvodaya Vidyalaya Sector 3. My favorite subject is science. Science is a very nice subject. My favorite game is cricket, and cricket is a very nice sport. And I am born in 13 January 2013. My fa- my my second favorite subject is maths. I am done, sir.
Very nice. Yes, Arjit, please say something about yourself.
My name is Ajay Srivastav and I live in Darbhanga, Bihar. My father's name is Basant Kumar and my mother's name is Poonam Kumari. I have two sisters. My favorite subject is science and mathematics. My favorite game is cricket and chess, and my favorite color is red. I'm done, sir.
Very nice, Arjit. Yes, Prince, please say something about yourself.
Yes, sir. My name is Prince Kumar Jha. I read in class 7th. I am 12 years old. I live in New Delhi with my family. I am from to Bihar. My father name is Mr. Sanat Kumar Jha. My mother name is Mrs. Putul Jha. And my school name is Sarvodaya Bal Vidyalaya. I have one sister. One sister. It is named Swati. My favorite sport is cricket. My my favorite subject science and English. English. I have done so.
Very nice, Prince. Yes, Piyush, today is Science Day. So please say those chapters you finished last week.
Yes, sir.
Please say something regarding those science subject you finished last week.
Sir, I am last chapter is light.
No, no, not a last chapter. Those chapters you you finished last week or last means those chapters right now running.
Hello, sir. Hello, Pankaj, sir. Can you hear me?
Yes, Aryan.
Okay, sir.
Yes.
Um,
So I asked to Piyush those chapters finished in class. Say something.
okay.
Yes, Piyush. So can you say something regarding those chapters you completed current?
Yes, sir.
Those chapters in science you completed in school. Can you say something in that chapter?
Sir, I am still completed chapter 4 science. 11 chapters is completed for.
What the name of chapters and can you say something regarding this?
Okay, sir. Nutrition in plant, nutrition in animal, acid, bases, and salts, physical, chemical, and changes, and its effects, light, motion, and time, electricity, circuit, and what and heat. Yes, sir. She is completed for my school chapters.
Aryan, Piyush.
Yes.
So can I have a question for you? Can you describe periodic motion?
Yes.
Can you describe periodic motion?
Periodic motion.
Yes.
Uh, mm, I have no answer.
Periodic.
So,
These events are used for the measurement of time. Periodic motion. Periodic motion. A pendulum has been used to make clock and watches.
uh, a periodic motion is like the Earth revolving around the sun. So, Pankaj sir,
Yes, Arya.
can, can I present something?
Okay.
Okay, sir. So yes, sir, I will be presenting about strange matter and how it is formed. So hello everyone, my name is Aryan. I'm 11 years old. So today I am going to tell something about strange matter and how it is formed and what are the implications of it. So introduction to strange matter. Strange matter is a theoretical form of matter composed of strange quarks. It is believed to exist in extreme conditions, such as those found in the cores of neutron stars. The property of strange matters differs significantly from ordinary matter due to its quark composition. So, this is a matter which has theoretical forms of matter that is called strange quark. So it is believed to exist in very high pressure conditions, and those can be found in the cores of neutron stars. So yes, Piyush, did you understand it?
Yes, yes.
Okay. So Piyush, can you read this slide for everyone?
Okay. The Thoughts model. Thoughts are fundamental particles that combine to form protons and neutrons. There are six types of twattons now has flowers, including up, down, and strange twattons. The combination of twattons give rise to various form of matter, including bryons and mesons.
Okay. So the quark model The quark model, quarks are fundamental particles that combine to form protons and neutrons. There are six types of quarks known as flavors, including up, down, and strange quarks. The combinations of quarks give rise to various forms of matter, including baryons and mesons. So these things are fundamental particles that combine to form the particles that we see here. So, Poonam, you have raised your hand.
Yes, Aryan. What is Byrons and Mesons matters?
So, as you see around yourself, the thing that you're seeing is baryonic matter, which is the normal matter that we are seeing. So, mesons are also a type of it. So,
Can you
did you
give me
get it?
another example?
Like, if I take a desk, for example, it is made up of wood, which is an baryonic matter. So, did you get it?
Yes, Aryan, but no much more.
Uh, can you repeat?
I can't understand.
ओके सो जो क्वार्क्स होते हैं वो फंडामेंटल पार्टिकल्स होते हैं जो फॉर्म कंबाइन होके हमारे हमारी जो चीजें देखते हैं हम उनको बनाते हैं जैसे बेरियोनिक मैटर अगर एक हम लोग डेस्क लेते हैं तो उसमें जो मटेरियल है उसको बैरियोनिक मैटर कहा जाएगा। आपको समझ आ गया?
Yes, sir.
ओके। so So, what are strange quarks? So, these are heavier than up and down quarks, contributing to the unique properties of strange matter. They play a significant role in the behavior of particles under extreme conditions. So, the presence of strange quarks can lead to a different state of matter known as strangeness. So, there are six types of quarks as you can see in the picture: up, down, strange, charm, bottom, and up, top. So yes, but these all four decay into up and down quarks. So these two uh, things are the are the things that make our surrounding, like protons, etc. So this strange quark is heavier than up and down. So like it is more heavier than both of them, and it is very stable and will not decay into anything. So does anybody have any questions? Okay, I don't think so. Poonam, do you have any question?
No, Aryan.
Okay. So, formation of strange matter. So, strange matter is theorized to form under extreme densities and pressures, such as those in neutron stars. When neutrons are compressed beyond a certain point, they may convert into strange quarks. This transformation can produce a more stable state of matter compared to ordinary nuclear matter. So, that said, the strange quark or the strange matter can form only in very high densities. And now moving to the next topic, characteristics of strange matter. So it is predicted to be more stable than ordinary matter at very high densities. It may have unique electrical and thermal conductivity properties. The existence of strange matter could lead to novel states of matter in astrophysical environment. So like this says, it can in it can turn anything that comes in contact with it into strange matter, but we need to have enough of it. So strange matter formation. So strange matter can form in cores of neutron stars, but they can only form in high temperatures of about 10 raised to the power of 12 Kelvin. But it is forming inside the star because of very high pressures in the core. The electroweak force turns half of the down quarks into the strange quarks. So, someone has raised their hand. Uh,
Yes, Aryan. I have a question.
okay.
What is electroweak force?
So, if you take quarks, they are three and are what you can call connected by some things that are called gluons. And if we apply too much force, so if we apply too much force, what happens that these gluons will create new quarks, and hence it needs very high temperatures or pressures to break that, and that can be found inside the neutron star.
Thank you, Aryan.
Okay, so did everybody understand it? Piyush, did you understand it?
No, I cannot understand it.
So जो स्ट्रेंज मैटर होता है वह एक प्रकार के स्टार के अंदर ही फॉर्म हो सकता है, क्योंकि उसके पास बहुत ज्यादा हाई प्रेशर होता है, और यह चीज बस 1 ट्रिलियन केल्विन पे ही बन सकती है, मगर ये न्यूट्रॉन स्टार में इसलिए बन रही है क्योंकि उसके पास बहुत ज्यादा हाई प्रेशर है.
होते।
So, so uh, Poonam, can you read this slide for everyone?
Okay, Aryan.
Okay.
The strange. What are strange stars? Strange stars are hypothetical stars composed entirely of strange matter. They are believed to be formed from the remnant of supernova explosions. Strange stars could differ significantly in structure and stability compared to typical neutron stars.
So, strange stars are hypothetical stars composed entirely of strange matters. They are believed to be formed from the remnants of supernova explosions. Strange stars could differ significantly in structure, stability compared to typical neutron star. So, mm, they are formed only in the cores of neutron stars because they have very high pressure. And when, how a neutron star is created, it is created after an supernova explosion from a very big star. So yes, so did everybody understand that?
Yes.
Okay. So neutron stars are formed when the collapse of a star occurs with such intense force that gravity forces subatomic particles such as protons and electrons to merge into neutrally charged neutron particles, releasing a shower of neutrinos. If the resultant neutral core is able to maintain form and not collapse into a black hole, the result is an extremely dense celestial object composed entirely of neutral uncharged particles. So, Piyush, did you understand it?
That's not understanding.
Okay. So, जो जो एक न्यूट्रॉन स्टार होता है वह तब फॉर्म होता है जब बहुत बड़ा स्टार वो कोलैप्स कर जाता है, और उसकी ग्रेविटी से जब कोलैप्स हो रहा होता है, जो दो पार्टिकल्स मान लो, प्रोटॉन्स और इलेक्ट्रॉन्स, वो इतने क्लोज आ जाते हैं कि वो मर्ज हो जाते हैं और वह न्यूट्रॉन्स बन जाते हैं, और उसकी वजह से हमें न्यूट्रॉन स्टार्स मिलते हैं जिन जिनके पास बहुत अ, जिनके पास बहुत सारा न्यूट्रॉन्स होते हैं कोर के अंदर. सो यस, पीयूष आपको समझ आ गया?
Yes.
ओके. सो यस, पूनम, पूनम.
ये सारी मुझे समझ में आ गया.
ओके. सो can you I have a question for you. Why there are no proton stars? It is an easy question. I have answered this, and the answer is just in the paragraph only. Do you know?
No, Aryan.
Can you try a bit?
Wha- Uh, can you repeat your question?
So why there are no proton stars?
Proton stars.
Yes.
Uh, no, Aryan, I don't know about it.
Okay. So can I know in which class you are?
In class 7.
Seventh. Okay. So when the collapse is happening, the gravity is so large that the protons and electrons are not able to handle it and combine and form a neutron particle, and that is why there are only neutron stars, because neutrons can handle the pressure only. So did you get it, Poonam?
Yes, Aryan.
Okay. So, strange stars. So, protons and neutrons are composed of three quarks: a proton by two up and one down quark, a neutron by two down and one up quark. It is hypothesized that within neutron stars, the conditions are so extreme that process known as deconfinement happens, where subatomic particles dissolve and leave their constituent quarks behind as free particles. The temperature and pressure would then force these quarks to be squeezed to such an extent that they won't form a hypothetical phase of matter known as quark matter. It occurs if the star becomes a quark star if the pressure is great enough. The could be affected even further and transform into strange quarks, which would then interact with the other non-strange quarks to form strange matter. If this occurs, the quark star would then become a strange star. So, Piyush, did you understand it?
Yes.
Okay. So, mm, can you explain to me what was in this present slide?
Yes.
Uh, okay, explain to me then.
होते
Okay.
अजीब सितारे प्रोटॉन और न्यूट्रॉन तीन तीन तरह से बने होते हैं। एक प्रोटॉन, दो अपवर्तों और एक डायनोवैक्स
Okay.
से एक
अ, मैं एक्सप्लेन कर देता हूँ हिंदी में। यानी कि जो
ओके।
प्रोटॉन्स और न्यूट्रॉन्स होते हैं वह तीन क्वार्क से बने होते हैं। एक प्रोटॉन,
हाँ।
दो अप क्वार्क के बने होते हैं और एक डाउन क्वार्क से, और एक न्यूट्रॉन
ओके।
दो डाउन से बने होते हैं और एक अप से। और ये कहा जाता है कि न्यूट्रॉन स्टार्स के अंदर क्या होता है कि एक इतना एक्सट्रीम प्रेशर होता है कि एक चीज होती है डीकन्फाइनमेंट। जो तीन क्वार्क होते हैं वो मानो कि अगर उनको सेपरेट करने की ट्राई किया जाए, यानी कि उनको निकालने की ट्राई किया जाए तो नहीं होता। बट इधर इतना एक्सट्रीम प्रेशर होता है कि वो जो क्वार्क्स होते हैं वो फ्री हो जाते हैं। तो इसको कहते हैं क्वार्क स्टार। और अगर और डेंस हुआ तो वो जो इलेक्ट्रोविक फोर्स है आगे डाउन क्वार्क्स को स्ट्रेंज क्वार्क्स में बदल देगा। आपको समझ आ गया पीयूष?
यस।
ओके। सो पूनम,
यस आर्यन, मैं समझ
so,
गया।
okay, so can you explain to me?
अ, कि जो प्रोटॉन्स और फिर न्यूट्रॉन्स जो होते हैं वो तीन तरह के वो क्वार्क से मिलकर के वो बने होते हैं। क्या मैं ठीक बोल रहा हूँ आर्यन?
हाँ।
अ, जो कि एक क्वार्क एंड डाउन क्वार्क, ओके। और फिर एक जो न्यूट्रॉन जो होता है न्यूट्रॉन, तो वो दो डाउन क्वार्क से वो बना होता है और एक अप क्वार्क से।
Okay, so
I'm done, Aryan.
can you explain to me what deconfinement is?
No, Aryan.
Okay, so जो वह तीन पार्ट वो क्वार्क्स होते हैं उनको साथ में एक पकड़ने वाला चीज होती है, वो ग्लूऑन्स होते हैं। अगर बहुत ज्यादा प्रेशर लगाया जाए तो वह ग्लूऑन्स अपने अपने क्वार्क्स फॉर्म कर लेते हैं। और अगर बहुत ज्यादा ही डेंस या गर्म चीज हो तो वह फ्री हो जाते हैं, यानी कि जो ग्लूऑन्स होते हैं वो मिट जाते हैं और वह फ्री हो जाते हैं। जो क्वार्क्स होते हैं फ्री हो जाते हैं। और अ, और उसके बाद वह एक क्वार्क स्टार होता है। और मान लो अगर ज्यादा फोर्स और डेंसिटी हुई तो वह जो आधे डाउन क्वार्क्स होंगे उनको स्ट्रेंज स्ट्रेंज क्वार्क्स में बदल देगा। तो वो क्वार्क स्टार में फिर उस क्वार्क स्टार में दो दो डाउन की जगह एक डाउन होगा और वन अप होगा, और उसके बाद उसके साथ एक और चीज, एक स्ट्रेंज क्वार्क होगा। सो डिड यू गेट इट पूनम?
Yes, but can you give me another example?
Uh, mm, okay, so like in, if you boil water, what happens that the molecules are set free and become gas. But in that thing, it is like a super fluid in that case. So did you get it?
Yes, Aryan.
Okay. The so Poonam, would you like to read this one?
Okay, Aryan. It is the equation of state. The equation of state describes how matter behaves under different conditions of pressure and temperature. For strange matter, this equation can indicate stability at densities beyond those of neutron stars. Understanding the equation of state is crucial for predicting the properties of strange stars. I'm done, Aryan.
What did you say?
I'm done, Aryan.
Okay. The equation of state describes how matter behaves under different conditions of pressure and temperature. For strange matter, this equation can indicate stability at densities beyond those of neutron stars. Understanding the equation of state is crucial for predicting the properties of strange stars. So, like as you can see in the picture, uh, the volume 2, the gas molecules are much closer than in volume 1. So yes, so this can also increase density. So yes, so the stabilities of strange stars. So they may be more stable than neutron stars due to the presence of strange quarks. Their stability could prevent the collapse into black holes under certain conditions. The stability allows a strange star to exist potentially longer than typical neutron stars. So yes, so these stabilities can allow strange stars to exist longer than a typical neutron star. Like if a neutron star can live for 1 billion years, but if it was a strange star, it would live more. So yes, Piyush, did you understand it?
Yes.
Okay. So do you have any question?
नो अभी तो नहीं है
Okay.
पते
Observational evidence. There is currently no direct observational evidence for strange stars. However, certain neutron stars exhibit properties that suggest the existence or the presence of strange matter. Astronomical observations continue to search for signatures that could indicate strange stars. So, okay. So, ladies and gentlemen, any questions for me? Okay, I don't think so. I think so. There is someone named as Vishal Agrawal. So, yes. So Vishal, would you like to read this slide? Okay. So
Hello.
yes.
Yes. Please repeat again.
So what is your name?
Vishal.
Okay. So would you like to read the slide?
Yes, yes, yes.
Okay, you can read this slide for everyone.
One question. What is the electron charge?
Uh, can you repeat?
What is the electrons charge?
I think so. One by three. Uh, yeah, I think so. Around this, I don't remember clearly.
Okay. Same like this. Electrons, protons, and neutrons.
What?
What is charge of electrons, and protons? Same like this. Neutron.
Okay, I think so. It would be mentioned in the slide only. Uh, so yes, I think so. It was mentioned here. So yes, so here you can see the charges. So the neutron is 2 by 3 minus 1 by 3 and minus 1 by 3, so which equals to 0. And the proton is 2 by 3 plus 2 by 3 minus 1 by 3, which is plus 1. So did you get it?
Okay.
Okay. Yes. So over here, the role of gravitational waves. So gravitational waves can provide insights into the behavior of neutron stars and potential strange stars. The merger of neutron stars may reveal information about their internal structure. Detecting gravitational waves from such events could hint at the existence of strange matter. So these can also provide some insights into the behavior of neutron stars and strange stars if they exist. So the merger of neutron stars may reveal information about their internal structure. So yes, what happens in a typical neutron star? The gravity and the density is so high at the core. There is one thing called nuclear pasta, which is told to be the what can call the strongest thing in the universe. So you can search it on Google. It has some weird images. So yes, strange matter versus ordinary matter. So strange matter is theorized to be more stable than ordinary matter under extreme conditions. It could have different interaction properties affecting its behavior in astrophysical processes. Understanding the differences help scientists explore fundamental physics beyond the standard model. So yes, strange matter is more stable in extreme conditions. So it could have interactions with things affecting its behavior. So like it can make more strange matter by touching it. So yes, so theoretical implications. So the existence of strange matter challenges our understanding of particle physics. It raises questions about the limits of matter stability and the forces at play. Strange matter could have implications for cosmology and the evolution of the universe. So yes, it can raise many questions about this matter stability and the forces. So, ladies and gentlemen, do you have any questions for me? So, Poonam, do you have any question?
No, Aryan.
Okay. Now, strangelets. So, strangelets are hypothetical small fragments of strange matter composed of a few strange quarks. They could potentially form during high energy collisions, such as those in particle accelerators. The study of strangelets could provide insights into the properties of strange matter. So, like a bunch of strange quarks can form into strange matter, and then a bunch of strange matter can form a strangelet, which can infect anything and will uh, make more strange matter. So, if strange matter can be produced or harnessed, it may have innovative applications in energy storage. Its unique properties could lead to breakthroughs in materials, science, and engineering. The study of strange matter could also impact our understandings of fundamental physics. So, yes, someone, so Prince, so yes, so Poonam, do you have any questions now?
No, Aryan.
So, are you understanding everything?
No, I am
Uh,
not
but uh,
understanding.
Okay,
but Aryan, I have a question.
okay.
What are strange matters?
So, strange matter, if you gather a bunch of strange quarks, it can form into strange matter. And if strange matter, we have a bunch of strange matter, then it can form a strangelet which can infect anything with, with the touch of it. So, did you get it?
Like virus,
Yes, it is more like burning, I think so.
burning.
Yes, if it like if it is dropped on a planet, the planet will become a strange matter planet. So yes, so uh, Piyush said that he is not understanding. So like अगर बहुत सारे क्वाक है स्ट्रेंज क्वाक और जो अगर बहुत सारे स्ट्रेंज क्वार्क्स आ जाए साथ में तो वो स्ट्रेंज मैटर बनाते हैं और बहुत सारे स्ट्रेंज मैटर आ जाए साथ में तो वो
Yes.
स्ट्रेंजलेट बनाते हैं और अगर मान लो अगर इसने किसी चीज को छू लिया एक ग्रह को छू लिया तो वह ग्रह स्ट्रेंज मैटर का बन जाएगा आपको समझ आ गया पीयूष
मतलब अगर इन्होंने किसी भी प्लेनेट को छू लिया तो वो स्ट्रेंज प्लेनेट बन जाएगा.
हाँ
ओके.
ओके so current research so scientists are conducting theoretical and experimental researches on strange matter and strange stars. Particle accelerators and astrophysical observations are key to understanding these phenomena. Ongoing research aims to identify potential signatures of strange matter. So yes, there is many research going on about this strange matter and strange stars. So yes, so challenges in detection. So detecting strange matter is difficult due to its nature and extreme conditions required for its formation. Current technologies may not be sufficient to observe strange stars directly. Researchers are developing new methods and models to improve detection capabilities. Implications for astrophysics. The existence of strange matter or strange stars could alter our understanding of stellar evolution. It may also impact theories related to supernova and the formation of black holes. Understanding strange matter enriches the field of astrophysics with new questions and possibilities. So yes, future directions. So future research will focus on both theoretical models and observational techniques. Collaborations between astrophysicists and particle physicists will be essential for progress. Advancements in technology may eventually lead to the discovery of strange matter. Conclusion. So strange matter and strange stars are very contagious and can turn anything into them. Strange matter forms in the core of stars, neutron stars, where deconfinement happens and quarks are freed due to the pressure and can turn strange quarks and then into strange matter and a bunch of strange matter into strangelets. It is suggested it is the most stable thing in the universe. So yes, we are now on the end of it of the presentation. So any questions? So yes, uh, uh, does anybody have any questions? Piyush?
No, no, no.
So can you explain to me what is strange matter? Okay, Poonam, can you explain it to me?
I can't explain.
Why? Uh, so can you explain a bit also?
स्ट्रेंज मैटर प्रत्येता एक तल्पनानिक स्वाधीन रूप है जो स्टोरेज वैद से बना है strange thoughts are subtleties particles that are not grouped into separate particles like in protons and neutrons की तरह अलग अलग चरणों में समजित नहीं होते हैं बल्कि एक एकाल द्रव्यनित बनाते हैं
Okay, so yes. So Pankaj sir, when will Malik sir join?
Yes, I also messaged him, but till now no any reply received.
Okay, so uh, is Amarnath sir joined?
Yes, we have a time till 9 p.m. time. So no,
Okay.
join. We
So
have 15
yes,
minutes more. So yes, Prince,
I don't think so. Is here.
Prince,
Yes,
please
sir.
say which chapter you completed now in school in science, and yes, explain something regarding this.
So light.
Okay. So so how, do you know much about it?
Yes, concave mirror, concave lens, convex lens, convex mirror, erect image, magnifying image.
No, I am light. I am talking about light itself.
Yes, light travel along a straight line. Any polished,
Okay, I will
any
ask you a
polished for
question.
yes.
So, what is the speed of light?
What is the speed of light? 29 crore 97 lakh 92,458 meter per second.
Okay. So, does light? How does light travel?
Light always
light is
travels in a
travel a
straight
straight
line.
line
Yes. So today, Amarnath sir has joined. Hello, sir.
Good morning, sir.
good evening sir
Good evening, sir.
Good morning, sir.
Yes, sir.
Good evening, sir.
Please unmute, sir.
Good evening, everybody. How are you?
Yes, sir.
Yes,
Fine.
sir. Fine, sir.
Wow, I see all the students today. Where are the teachers?
Sir, I am
Sit.
the only one here.
You are the one today, teacher. Good, good, good. All right. So Aryan is the teacher today. So very nice.
Uh,
Okay, kids. So ask him question.
so
But it's yeah. Continue.
so I think so. Poonam had a question. Poonam, you had raised your hand.
No, no, it's a currently
No, Aryan.
we discussed regarding light, na, right?
Yes, we were talking about light.
Yes, Prince.
Uh, Aryan, I
Yes.
think speed of light is 3 lakh kilometer. Sorry. Uh, yes, I think 3 lakh kilometer per second. Am I right?
Okay, so
Three.
it is approximate, but the
Yes.
real answer is 299,792,458. So yes, we we approximated it to 300 for the sake of convenience. So yes, uh, Prince, uh, do you have any questions about light?
I have question in nutrition in animal.
Okay,
I have discussed
okay, you can say the question.
what is what is ruminants.
What is he left? Okay, okay. So
Yes, Arjit. Which chapter you just completed in school? Please
Yes,
explain
sir.
something.
Yes, sir. The last week I was completing my chapter 11, transportation in animals. Sorry, I think transportation in substances. I think.
okay, so yes. So Poonam, do you have any idea about work, energy, etc.?
Uh, what is
Uh, do you have any idea about energy?
energy? Uh,
Yes.
okay. So
So I'm
please wait for a few seconds.
I'm telling that. Do you know the Kardashev scale? Do you know
What is
the
our cardio?
Kardashev scale?
Cardio skin. I don't know.
Okay. So like it is it is based on the energy consumption. So like there are four types of civilization. F- Type 1 which controls its planet, type 2 which controls it which controls the solar system, third type 3 controls the whole galaxy, type 4 controls the whole universe. So like we are on 0.75 around this number, and we have not yet reached type 1, and we are I think so using around 18.87 multiplied by 10 raised to the power of 13 watts of energy. But if we want to go to the type 1, we need to use around 10 raised to the power of 16 watts. So like if if you want to know anything etc, like how much how much energy it is using etc, so right now we can burn around uh, 2 million chickens per second if we used our energy. So yes. So Poonam, uh, do you have anything to say about Kardashev scale?
No, Aryan.
So yes. Does anybody have any questions?
Yes,
No.
yes.
Okay,
What is
Prince,
ruminant?
what's the question, Prince?
What is ruminant?
What is remnant?
Yes.
So can you give me a hint? I think so. Yeah. So can you give me an idea about it?
Ruminants. Yes.
So what it
uh,
is related to?
Nutrition in animals. Digestion part in animal.
Okay, I don't think so I have
A
any.
ruminant is a hoofed mammal with a four-chambered stomach that chews its cud. Ruminants include cattle, sheep, goats, deer, camels, hares, bison, and more.
You
A
can
ruminant,
explain it.
So was that the answer, Prince?
What
Uh,
is ruminants? Just
what what is
ruminants.
illuminates? Okay, I think so. It is related to biology, and I have no idea about it. So
Uh, can I explain it?
okay,
Some I think they are grass-eating animals. Have a
yes, yes,
very. Am I right, Piyush?
are you
yes.
talking about herbivores?
No, no, no. न्यूट्रिशन इन एनिमल में है ruminants जो
Ruminate.
पिक्चर में दिखाई है.
Yes, I think they are grass-eating animals, and they have, I think, four chambers of in their stomach. That is
Yes,
first rumen. I think number two rectum. Number three. Uh, Number three. I think I forgot it about. But number four is uh, I think abomasum. Fourth part of ruminant ruminant stomach is, and the third part. I think I forget about that. What is the third part of the ruminant?
Okay.
no ruminants have a four-time reticulum, aposium, obesium, or rumen.
So so Prince.
Yes. Yes. I was just said that ruminant has four types,
Yes,
four
yes,
chambers in their stomach. That is rumen first, and
yes.
second rectulum, reticulum. I think, uh,
हाँ,
and number three is omasum. I
हाँ.
think, and number four abomasum. Am I right?
Yes, yes.
So yes, uh, moving to the next question. So Prince, do you have any further questions?
Yes. What is amobia?
Amoeba. So amoeba is like a single-celled organism. Uh, am I speaking right? Did you meant amoeba? It is a single-celled organism.
Yes.
It's done, Prince.
Yes, sir.
Yes, Visarji, you have any question regarding our kids? Or you want to say something? Because your background is also science, right?
Yes, sir. No, in which
Okay, okay. So, Aryan, please tell us which chapter you completed in school last.
So my school, uh, they have given holiday.
No, no, right now holiday, right now at 9 p.m. It doesn't matter, but which science chapter you completed in school last?
So it was about magnets.
Can you explain?
So I think so. Magnets. Magnets are things that attract metals because of their charge, and they can point in the geographical north of the earth when suspended freely. So yes, this was the whole chapter in some simple words. So yes,
So other kids, you have any question? Want to say something regarding magnet?
Yes, sir. My question is for Aryan. What is Tote mirror and the difference to Tonvat's mirror?
okay, Prince.
Are you asking?
So can you answer that question?
Yes, Arun.
Okay.
Concave mirrors.
Please always received question. Sorry, please I have received a call. Okay, okay, please.
Yes, left. So, Arijit, do you have an answer for that?
Yes, Aryan. Something I know that about it. These mirrors are curved inwards, and the inner side uh, of like the inner side of the spoon is curved in the inwards. So uh, the spoon is the best example of the concave mirror. So
Okay, so yes. Any further questions? Okay. So, should I ask a question? Arijit,
yes, Aryan.
I have a tough question for you. Uh, if you do the maths, it would be easier. So, like, assume that there is a circle which has an area of 10 raised to the power of 7 meters. And so, can you tell me how many people can sit in it if a person occupies an area of 10 raised to the power of minus 1 meter? So, yes, it is a tough question. Uh, Poonam, do you have an answer for that?
No, Aryan.
Okay. So, yes.
You guys, I have a question. Have you guys yet studied in your school how to calculate the area of a rectangle, a square, triangle?
Yes.
Yes, sir.
Okay, so then you should be able to answer his question then, right?
Yes, sir.
What
Sir,
is
but
the how do you calculate the area?
no, sir, I have already given the area, which is 10 raised to the power of 7 meters.
Uh, so okay, so the area and how much is each person occupying?
10 raised to the power of minus 1 meter.
Okay, so then have you guys also done this math where the power there is addition and subtraction and multiplication, all those kind of things,
So, okay.
logarithmic base? Have you done it? Because that is the math background you need.
Yes.
Okay, so you have to explain again to them. Probably they don't know that math yet. Not all of them, at least.
Okay, so if the area is 10 raised to the power of 7 meters and a person occupies 10 raised to the power of 1 minus 1 meter, so then what will happen that 7 plus 1 happens, and there there can be 10 raised to the power of 8 people sitting in that circle, in that field, you can say. So,
It's not
sir,
possible. So then it's not possible, right?
so like we are talking in maths, so there will be 10 raised to the power of 8 people sitting in that field if all the area is covered. So, sir,
I think they didn't get it. So what you have to do is let's use a little piece of paper to explain to them. 1 second. Let me see if I can find something to write on, and then we will, with your help, we will do that presentation here. Quick one. So let me see here. Okay, I found things
So
like this. It's always good idea, Aryan, to show
yes.
it on the piece of paper. Like share your screen and show them the basic uh, how the power works. So that way
Okay.
everybody can understand. So okay, I got it here. Let me see. How do I do the power thing here?
Okay.
So let's see if I can write something here. Then I will say. Okay, so it should be sharing something. Let's see quickly. Yes, it's came.
Okay.
Yeah. So kids, I just want you to see how do I write 10 to the power 1. So 10 to the power 1, I think if I write 1, will be subscript or superscript. I'm not too much format.
Sir, should I do is so should I do that? I can put can
Yes,
code.
you should. Yeah,
Okay.
that's what I wanted you to do. So explain to them that 10 to the power 0 is what, 10 to the power 1 is what, 10 to the power 2 is what, like that. Go all the way to the and
Okay.
then similarly 10 to the power minus 1 is what, minus 2 is good. And then you tell them that if you multiply them together or add them together, how their power gets added or subtracted. Okay, that is the whole math you should explain to them. Then they will appreciate what you are trying to ask, because right now they don't have background to understand your question. They did not understand your question.
Okay, sir.
Okay, good. So why don't you do it then? Share your screen and show
Sir,
them
I
math.
sir I have shared, sir.
Oh, okay. All right, good.
Okay. So like there if one person is occupying this much area, so then if there are 10 people, this will change into this will be cut off, and if there are 100 people, there you can say that these amount of people are there, and so the area is this, uh, and the amount of people, amount a person is occupying is this, and if I will do the maths, that will be 10 raised to the power of 8. And so if if um, sir,
Okay,
I don't
so
think so we can
no, no,
explain
no,
it
no.
but
Okay, I want you to write a simple formula, 10 to the power n, write one term, 10 to the power n,
yes.
yeah, below that, not n and m, right? Not just write simply n, and then another one should be 10 to the power m.
So yes, sir, what should I do with the m?
No, you wrote the top one. The first one you wrote 10 to the power
Please clear
m.
all. Please, yes.
Yeah,
Okay.
10 to
it
So
should be
sir,
only 10. Write only 10 to the power n. No, 10 to the power n. I'm not
10 to
asking
the
n.
okay, 10 to the power
10.
of
Yeah.
sir. Wait,
Okay.
I think so.
Small n, or that's fine. No, why you are writing like that? Why you are writing that arrow thing? There is no need
only
for that.
10 to the power n.
So
Not nothing symbol of powers
Yeah,
anything.
that
Only
symbol is
simple.
should not be there.
okay, sir.
Everybody knows. Yeah, this is the right way of writing it. Another one you write below that 10 to the power m. Okay.
Okay, sir.
So again, you need to remove that one. There is no need for writing that one. That extra thing you have written. Okay. So now, uh, so there are two things, and also write below that 10 to the power 0 and 10 to the power 1.
10 to the power of 0 and 10 to the power of 1. Yes.
Okay. So write, tell me 10 to the power 0 is how much? Equal to, write down that number. If if 10 to the power 0 is mathematically is how much?
Sir, it's 0.
Okay. And 10 to the power 1 is how much?
Sir, 10.
Write down. And 10 to the power 2 will be how much?
Sir, that will be 100.
Okay, so kids, everybody, I want you got it this one, right? So now you know what is 10 to the power 0. 10 to the power is nothing but 0. This is another way of writing. Similarly, 10 can be written into 10 to the power 1. Okay, but you can say that what is the point in doing this? Why should I write it? Say for example, right now, if I ask you to write 10 million, there are two ways you can write 10
Yes.
million. One will be like 10, and then you put six zeros on top of this. That will be
Yes.
10 million, right? So,
Yes.
so can you practice it? Let's do the show them here. Write 10 million in Ankh. I mean, can you do it like 10 and then put the six zero in front of it? Okay, good. No. So that will be 10 to the power 6. This is one way of writing
Yes.
10. This is 10 million, right?
Yes,
But
sir.
another way you write it down equal to, just like you did 10 and 0, right here equal to. No,
Sir,
just you can do it right there on the top corner. You have 25 over 6 is equal to how much in like 100, right?
okay,
Show
sir.
me that.
Yes, sir.
Okay. Okay. So did you get it? I think you got more than that, or it's correct, right?
Yes, sir.
It's a 1
No,
crore.
no, you got already one more. You have to remove one extra zero you have.
Yes, sir.
Okay. So 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 now, okay, good. So now you see there are two ways of writing. If you want to write like, what is this? Ekai, dahai, saikara, hazar, 10,000, lakh, 10 lakh. Look at it. How much time did you waste? How much space it took?
Yes,
and
sir.
but rather than writing this, what is this, 10 lakh, right? 10 lakh, we said, right?
Yes.
10,000, lakh, 10 lakh, 10 lakh. uh, there is another way of writing 10 to the power 6. So what you have done is, if you count the number of zeros, how many zeros are there? There are six zeros.
6.
So it's very
Yes.
simple. 10 and to the power 6. Similarly, if I ask him to write uh, million, he will need to add, I think, three more zeros. So either
Yes.
he can write here three more zeros, or he can simply change it to 6 to 10 to the power 9. Okay.
Yes, sir.
So same, so large number, you see that is another way of expressing. And now I'll show you another importance is that, say for example, I mean, he already explained to you what is 10 to the power 0 is nothing but 0. 10 to the power 1 is nothing but 10. 10 to the power 2 is equal to 100. Now, rather than saying all this, suppose if I simply write it 10 to the power n, and if I say n is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, now it means that all I need is, every time I need to change n, and the number will change, and then you have a new number.
Yes, sir.
So this is what is also, when you go to the advanced level mathematics, you play with many numbers, not only one number like this one. So that is called a series. You will have a series: 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3, 10 to the power n, 10 to the power blah blah blah. And you can do mathematical equation on the whole series. Okay.
Yes, sir.
So that is why we want to understand this is called indices. Indices, right? That's what you call in English, I guess. Indices.
Sir.
Yeah.
Yes.
Okay. Now,
Exponents also, I think so.
exponents. Okay. Now another thing is that you see 10 to the power n and 10 to the power m. Suppose if you want to multiply them together, you can do it. Can you multiply 10 to the power n and 10 to the power m? Show them together, 10 to the power n, and then equal to 10 to the power n plus m. Can you do that for them?
So, sir, like
Write
what?
another. Okay, 10 to write 10 to the power n times, multiply it. No, no, do it there, right there. Multiplication sign there.
Okay,
10
multiply.
to the power n times whatever is the multiplication, right? Sign. That's where you multiply. No, you multiply it a little below and you simply have x sign, right?
Yes.
Use the common, yeah. So we use, instead of that, use simply x. 10 to the power n, x, and 10 to the power m. Okay, again, you have taken that arrow thing. You don't need to do that one.
Yes, sir.
Okay, yeah.
Sir,
No, right?
no, sir. I'm
Sorry,
rewriting it, and then multiply by 10 raised to 10, and then
power
m.
m.
Yes.
Okay, so now, and say below that one, you say that n is equal to 2 and m is equal to 3.
So yes,
n is
yes. So, sir.
n is equal, below it, right below it, right now, not
Okay.
there, below.
So yes, 10.
No, I said n is equal to, what is, I write it down for everything, you have to write it down. N is equal to 2 and m is equal to 3. You
So
didn't
10
write that.
to
And I said n is equal to
n.
2. Yeah, yeah, that's fine. Okay. And m is equal to 3.
No, no, it's simple, Aryan. N is equal to 2 and M is equal to 3.
Yes.
First of all,
Okay, good,
no,
good,
no,
good. So you have it here, but above this line, you write. I want them to know that how it is changing. N is right. First equal sign before that you write n equal to make it 2, another comma, then make n equal m equal to 3. That's all you have to do. Yeah. You see?
So, sir, then, sir, is the answer correct? 10 raised to the power of 5?
Yes, that is 5, but you have not explained to the class. That's what I'm trying to say. That you haven't written. You should write it down that n is equal to 2 and m is equal to 3.
So,
Where is that?
so, sir, that is like multiplying 1000.
No, n is a variable. I want to show them what is n right now. They don't know.
And
So
this,
you say that n is equal to 2. Already you have answered the question, but you have given the answer, but you have given the complete answer, but you didn't give the complete question. I wanted them to as suppose if the bottom line is not there, 10 to the power 2, 10 to the power 3, 10 to the power 5 is not there. Okay, okay, so they should know. I want to ask them that tell me n is equal to 2 and m is equal to 3, and then solve the problem. So your question is incomplete. You see what I'm saying? Okay, now you have got it here at the bottom. That's fine too. Okay, so now you kids, you understand what he is trying to do? He is trying to multiply 10 to the power n times 10 to the power m, and where n and m can be anything. So rule says that if you have like this 10 to the power n and 10 to the power m, all you do is that you add the n and m together. So it will. That's what he has done. 10 to the power 2 plus 10 to the power 3 times 10 to the power 3. It becomes 10 to the power 5.
yes, sir.
So so, and how the 5 comes? Simply the power gets added. They don't get multiplied. You have to keep in mind. 2 plus 3 is 5, not 2 plus 2 times 3. So what? Although he is trying to do multiplication of two numbers, but when he does in the indices form, exponential form,
They
only
add.
power gets added.
Yes, sir.
Okay. Okay, so now
Sir,
you ask the kids if everybody understood, and you ask them to make an example. Everybody has to make one example of n and m and give us the answer.
Sir, I think it's a formula is when the base number is same
Yeah,
and the power number is different, so we add the power.
good, good, good. Yeah, that is exactly he is doing here. You see that?
Yes, sir.
That is exactly what he is doing. So, so here base is the same. What is base? Is 10, right?
Yeah.
In both
Sir,
cases.
base is 10 and power is 2.
And another power is what? Another power is in the
3.
second term power 3. So
Yes,
that's
sir.
why. So as per his answer, the power should be added, right? And that is
Yes.
exactly Aryan has done. He added 2, base he kept the same 10, and he added power 2 plus 3 equal to 5. Okay, now you go back to your original question and show them mathematically what happens. Your 10 to the
So,
power 7 and divided by 10 to the power minus 1, how it is coming. Now let's do this math. Basic is done. No. You had 10 to the power 7, right? Your
oh
original
yes,
question was,
yes, 10 raised to the power of 7 multiplying
yeah,
10 raised to the power of minus 1. Wait a minute, I should erase this. So yes, uh, so sir, these two powers will get added.
so how much will be that?
So sir, that would be 10 raised to the power of 8. So yes, I think so. I wrote that.
But sir, I think uh, when plus and minus, when we multiply plus and
Yeah,
minus, that answer is minus, so I think it
yes.
is minus 8.
So
No,
Aryan, he has a question. He is right. 10 plus minus 1. So
sir, am
plus
I right?
minus that becomes minus 1. So it should be 10 to the power 6. Isn't that correct?
Oh sir, can you repeat?
Okay. So right below math, if you have 7, 7 plus, write down 7 plus, in parenthesis, write minus 1. Parenthesis, write minus 1. I said in the quote, parenthesis,
It's a
right?
bracket. It's a bracket.
Yes,
Bracket.
sir.
Put it in the bracket minus 1. Close it. Okay. Solve this one. How much is this?
तो सर से जो 7 प्लस है और माइनस 1 है, तो सर जो नेगेटिव का साइन है वो तो प्लस तो उतारते नेगेटिव बन जाए, तो सही आंसर 6 है ना?
Okay, Aryan, what do you think? How did
So,
you get 8? It should be
sir,
6.
mm, sir, if sir, can I do this in another way?
Yeah. Do it
So,
the
sir,
way you like. Yeah. Yeah.
sir, this would be 0.1, and this will be this many zeros, and uh, sir, if I
No, no,
think
no,
so,
no, 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 no. Oh, okay. Uh, uh, eh, uh, don't confuse the class. This is a large number. They will not comprehend it. Okay, simply said, you said that your total area is 10 to the power 7, and one person is occupying how much? 10 to the power minus 1, right?
yes, sir.
Okay, so simply why don't we do it? 10 to the power 7 divided by 10 to the power minus 1. Let's draw a what you call it between 10 to the power 7 and 10 to the power minus 1. You have a what you call forward slash. That is a symbol for division, right? First
Uh,
do that. You show that how do you put the division sign between. Put
yes,
yeah. Okay. So now remove the bottom line. You have that number. Now try to answer in the power form. How much will be that? Take all this out. Take all this out. Now this is the question, original question you had, right?
yes, sir.
Okay. So that is why you were coming to the 8, I guess, probably. But if you solve this, how you're going to solve this? Kids, help him. How much, how it should be done? We already discussed the whole math here.
Yes, sir.
So base is
So,
the
sir,
same. Okay, so now you understand, Aryan. The very
Yes,
first thing is that you have to bring the base at the same level. Keep in mind, it is uh, in the case of multiplication, if the base is same, then power get added, right? But it is not a
yes,
multiplication. It is, what is it? It is right now division.
Dif- yes.
So first you have to change this division into multiplication. So how would you do change this division into multiplication? You have the power of 10 to the power minus 1.
Yes,
Something will happen to it. What will happen to it?
sir. Bracket. Sir, I think so. Bracket would be there.
No, no, no. Okay. No, you are 10 to the power 7 divided by 10 to the power
Mi-
minus 1.
Yes.
What sorry, 10 to the power 1. You have not 10 to the power minus 1, 10 to the power 1. So
No, sir.
basically,
It
what
is
you,
minus one. It is minus one, sir.
what? Okay, so are you saying that this power is here 10 to the power minus 1?
Yes, sir.
Okay, so if it is the minus 1, next one you write, if it becomes a multiplication, 10 to the power 7 multiplication, write it down. How much, what will become this number? The second term. Can you write the second line so that everybody can see it?
So, sir, this is 10 raised to the power of minus one, and this one is 10 to the power of minus 10 raised to the power of 7.
Yeah. So, but now if you, that's fine. But now you are trying to multiply it. So, if you do the multiplication, this sign will not be minus 1 anymore.
I- mm,
That is where you are not getting it. See, on the top line you have division sign there, right? Now I'm asking you put a multiplication sign here and then tell me what should be the second term.
so,
If you have, okay, suppose if you have a like in the division, 10 to the power minus 1 is how much? Minus 10 to the power minus 1 is actual how much?
so 0.1.
No. Is that
Uh,
correct? No, 10 to the power, if 10 to the power, yeah, 0.1, right?
yes,
Yeah,
sir.
but
No, sir, I
okay.
think the answer will be 10 raised to the power of 8. Like if I do this
No,
way,
that is, no, you, yes, that should be. So the question here is, which you are not doing, explaining to the class, is that how the power 10 to the power minus 1, when it comes into the play into multiplication, since it is the
so
denominator. So when it has to become first a numerator, when it changes from denominator to numerator, the power minus 1 will change. It will become plus 1. That is the part you are missing. And
uh,
and that is, and once that becomes plus 1, then 10 to the power 7 times 10 to the power 1, you have base is the same, so you will add the power, then that will become 10 to the power 8.
so
Class, any question? Did you get everybody this math? Everybody
No,
is clear
sir.
or still some question? Pius, you got
Yes,
it?
sir.
Everything is clear now? How we got 10 to the power 8, right? Looks like
Yes, sir.
Aryan is not yet convinced.
no, sir. No, sir. My answer is 10 raised to the power of 8.
Okay. So now you see your 10 raised to the power 8 was correct, but since you didn't explain, it appeared you are trying to explain to the class 10 to the power minus 6. But now you have explained. because your number was the second number you had was in denominator. So that is what I was trying to explain to you, that you are in the division form, 10 to the power 7 divided by 10 to the power minus 1. So first, to solve it, you have to have the same base. You don't have the same base. So first you have to bring this denominator into numerator. And if you bring the denominator into numerator, then mathematically the power will change.
2
And
plus 1.
minus 1. And now once we got, then it's very boom, very simple. Both base is the same, you simply add the power. Good. All right. I guess we are over the time. Pankaj, what is
Yes,
time
sir.
now?
Yes, sir. It's
Huh?
9:30.
Sir,
9:30.
9:27.
Yes, sir.
Okay. You guys have any more question? You want to talk anything else?
No, sir.
No, sir.
No, sir.
I heard you guys have a lot of vacation time now, right?
No, sir.
Well, on the first there is no class, I heard.
Yes, sir. Till
January
S-
first,
1st.
till 1st January, school is closed.
Yes,
Yeah.
sir.
So no
can
class. So no class on 31st, no class on 1st. So then why don't we continue a little bit more, because you don't have school to go tomorrow, right?
And luckily tomorrow is Sunday.
Oh, even better. So, so
Yes,
yeah, okay. So let's everybody ask one question, and whole class together as a team have to answer the question. So, who wants to be next? I think Piyush already asked. Who is Poonam Kumari there?
it's Arjit. Arjit, you have any question, please?
No, sir.
Oh, good. Arjit, thank you for raising your math concern, because you were right. Aryan was a little bit confused because he was trying to. Aryan is was he was trying to do the math in one step. You have to break
Uh,
it down, math, for
yes,
everybody to
sir.
understand.
Yes, sir. I'm explaining this because I'm read this about in my class because I'm reading
Good,
class
good.
7.
Oh, okay.
So
All right. So very good. Okay, this is why it is teamwork. Team is always more advanced than the individual. Okay,
yes, sir.
because
Yes, sir.
team has lot of different experience. So always problem in America, we stress that always try to solve problem in the teamwork. If you have a good teamwork, what happens is something you don't get it, somebody else gets it, and then you can take benefit of your friend. So that's why you should always have a lot of friends, communicate, and in education especially, if you share with each other, your knowledge enhances, it increases. If you have a rupees in your pocket, if you give to uh, $10, 10 rupees to Aryan, you will lose it, because you have less, $10 less. But if you give knowledge worth $10 to Aryan, like we had discussed right now. If now everybody learned what is the indices, or what is this, what you call, um, I don't know what you call
Power,
mathematically.
power.
Power thing we used to call indices in my days. INDICS, I think.
Sir, this is yes, sir.
Still call, yeah. It was 50 years back. Okay, so good. So kids, I'm glad that you guys are doing well. So what else? Anything new? Oh, what happened to that? There was last week you guys were talking that there is asteroid coming to the Earth. What happened to it? Any
Sir, it
news,
passed by.
Aryan?
Sir,
Passed by?
yes,
Nothing
sir.
happened.
No, sir.
Oh, so we are safe, huh?
Yes, sir.
But we have figured it out that otherwise, I mean, science is developing. You guys are new scientists. You will be future scientists. We have to come up with a
Yes.
model. How can we catch them, right, before they hit the earth? And
Sir, I
also,
have a question for you. Okay. So, sir, it is. Sir, God or science? So, what will you choose?
No God. There isn't God. Do you know anybody who has seen God?
Sir,
You tell
but
me. Okay, you hear in mandir, masjid, Christian church, everywhere you hear about heaven and hell, swarg and nark, jannat and jahannam. But I
sir,
want to know who has gone there and come back.
sir,
You
like
need an eyewitness. You need an eyewitness. So we are the scientific communities here. We're talking science. We go by evidence. We don't blindly believe anything.
sir,
That
let us imagine that all of that thing is fake. But even if there was a non-physical super intelligent being, if he needed to create a physical universe, he would need many constants, uh, etc., and matter to create things. So,
okay.
so then he created the Big Bang, etc., and like we have around 31 constants at that are very specific, and if they weren't right, if they weren't right, we the universe, we will not be able to, there will be no life if some of them change even a bit.
Hmm.
So yes, uh, so
So
my my
what
perspective
is
for God is very different.
what is the point you are trying to make, Aryan? What is your what you are trying to communicate to the team?
So sir, like,
What is? Uh,
so science can tell us how the universe was made and how the rules were settled to what you can call know things and the probabilities.
yes.
So yes,
So
and I
basically,
think so.
what I think, if I understood what Aryan is trying to say, that science is governed by different rules, right?
Yes,
And rules, constants are part of rules, and so um, uh, that is one of his comments. Second comment he made is that what we in science we call cause and effect. For example, if you see a smoke uh, somewhere, it means there is a fire somewhere, because smoke cannot be generated without a fire. Okay, so that is called in Sanskrit we call karja karan siddhants, and we exactly use that one in science. Very, we call it root cause analysis. Everything we try to figure it out why this happened, and then we try to see where this happened and how this started and what is the main cause. That is what we call it root cause.
yes,
So and this is the third dimension of this is evidence. Like everything happens, then when it changes from one form to another, it leaves some kind of trace. And so we need to find that trace, just like I gave you example of smoke and fire. That smoke is a trace, and we say that, oh, there is a smoke here on the mountain. It means there is a fire somewhere there on the mountain. And then from there we start digging, and finally we know exactly where the we can start going. We can take a helicopter to go to the mountain in that direction, and then we can go and see that smoke, and we find that, oh, there is a crater. I remember it. I was in
okay,
Oregon State, and there was a eruption there in the St. Helen or something. I don't remember it, and in the neighboring Washington State, and you could see a big, eruption of smoke coming from the mountain, big mountain, right? So that was not a fire like this one. That was like molten lava and all those kind of things was happening. So then the scientists figured it out that, whoa, this is not a fire. Forest is not burning. This is a different kind of geological action.
yes,
So, in science, we go by evidence, and if we think another part is that in science we don't lie. Suppose if I don't know something, there is no harm in saying that I cannot explain this, why this is happening. I got this result. I got this result by experiment, but I cannot explain completely right now. Okay. Do you
Okay.
think that? Do you think, like, for example, if I gave you many experiments, like Madame Curie, when she discovered uranium, do you think she had planned for it? No. She was trying to do some other experiment in physics, and then the byproduct of that suddenly, in the chemical reaction, the two things she was mixing it up, uranium came up, right? That was, and she was shocked and surprised. Initially she could not figure out when first time, so where this light is coming, where this come, what happened? But then gradually she started
Sir,
putting it together theory, and then she figured it out that it's uranium. Okay. Yes, go ahead, Arya.
sir, can I know what you are trying to prove?
I am trying to prove that in science, if there, I'm trying to say that in the science we is evidence based. That you have to have a proof, like 2 plus 2 is equal to 4. Then
Yes.
it is science. So science is something which has to be reproducible. Anybody should be able to duplicate that one. Okay, 2 plus 2 is equal to 4. Whole class can do it. If I say, if I say, no, 2 plus 2 is equal to uh, minus infinity, then everybody will scratch their head and they say, sir, how you are coming? You will give me a little benefit of doubt because I have a little more experience. Then maybe sir has a good idea, but how is coming? And then you will, in your head you will be asking the question that he has to explain to us, right? And
Yes.
I will not be able to explain. So if suppose, even if my assumption is correct, if I don't know how to explain, I'll say that I don't know. I came to this conclusion, but I don't know how, why it happens. So it's okay to admit in science. That's what I'm saying. That
Okay.
something you don't know, it's okay to say that one. That I don't understand the logic behind it, but this is the result by experiment. So there are theoretical physics and there is experimental physics.
Yes.
Exper- Experimental physics, you do the experiment and then see some results, right? Theoretical physics, what is that one? They analyze that the experiment you have done, and they will say that this is what you did step by step, and because of this, what you did, you got this result. Sometimes they cannot analyze the whole thing, so they say that I don't know. My analysis is not complete. Sometimes some analysis goes for 100 years, 10 years, 15 years.
Okay.
I was reading an article about a mathematics student. So one day, Aryan, this is a very interesting story. I forget the name of that mathematician. So one day, one student in the college, master's level or PhD level class, he went late and he saw that his mathematics professor has written